About negative exponents today, and not just that, we're also talking about exponential growth. So what's 3 squared equal to? 3 times 3 is 9. This is kind of bugging me. I'm going to do a new page. Bugging me. What's 3 to the negative 2 equal to? Shh, boys, we're starting. Right, it's equal to, negative exponent basically means reciprocal, so it's 1 over 3 squared, so it's 1 over 9. Has nothing to do with positive or negative value. And then, what do we do with the exponents when it's like 3x squared plus 4x squared? What do we do with the exponents here? Nothing. What do we do with the exponent if it's 3x squared times 4x squared? Add the exponent. So 3 times 4 is 12, x squared times x squared is 2 plus 2, not 2 times 2. Because basically this means x times x times x times x to the 4th. What do we do if it's 3x squared cubed? Right, it's 3x squared times 3x squared times 3x squared. So it's 3 times 3 times 3. 3 cubed is 27, and it's x squared times x squared times x squared. So basically it's 2 times 3. So multiply. So this is an add the exponent situation, x times x. This is a multiply the exponents situation, power to a power. Oh, that'll get us going until we get to the green boxes. All right, number 1. A. Do you guys love it when we have A's and B's and C's? The fun don't stop. Okay, let's try this without a calculator. What's negative 4 to the negative 2? Well, what's negative 4 squared? 16. So if it's to the negative 2, what's it going to be? 1/16. Just flip it, reciprocal. B, what's the difference on B? What's negative 4 squared? Okay, on this one, the negative is not in the parentheses, so it's not being squared. It's kind of an order of operations thing. You square the 4 first, and then you add the negative. So it's the same thing as A, except for it's negative. So on 3, what do we do first? 5 times 2 or 2 to the negative third? Yeah. Exponents come first in order of operations. Parentheses, then exponents, then multiply. So what is 2 to the third? 8. 2 times 2 is 4 times 2 is 8. So what's 2 to the negative third? 1/8. What is 5 times 1/8? Remember, if you're doing 5, it's 5 over 1 times 1 over 8. So it's 5 times 1, 1 times 8. 5/8. B. So parentheses, this one is different because there's parentheses, so we have to do that first. What's 5 times 2? 10. What's 10 to the third? 10 times 10 times 10. You know what happens each time you multiply by another 10? Adds a 0. So 10 times 10 is 100, times 10 is 1,000, 3 zeros. So what's it going to be if it's 10 to the negative third? 1 over 1,000. Okay, what did we say on 5 to do when you have a power to a power? Multiply. It's negative 2 times negative 1. Positive 2. So x squared. And then on B, you got a power to a power to a power. What do we get if we multiply all those powers together? 0. What is anything to the 0 equal to? No. 1. Okay, the reason it's 1, do you guys remember, I didn't mention this one yet. What do you do when you're dividing the same base? What do you do with the exponents? Subtract. And what's anything divided by itself always equal to? 1. So that's kind of where the anything to the 0 equals 1 comes from. Alright. Number 7. So both of those things are to the negative 1. What is 3 to the negative 1? 1/3. What's a to the negative 1 to the negative 1? What do we do with the exponents? Multiply. Negative 1 times negative 1 is 1. So it's 1/3 times a, or the way the book probably wrote it, it's a over 3. Technically 1/3 a would also be correct. Oh, sometimes it's hard to find where the book wrote their version, but yeah, they can write it. Okay, for B, oh gosh, what a mess. So the whole thing is to the negative 1. On this one, you cannot just distribute out that negative 1 exponent because all of it's to the negative 1. So we're going to start out with 1 over 3 plus, and then there's an a to the negative 1 right there. So that's the same thing as 1 over a. 1 over 3 plus 1 over a. Would the book do something with that? Yeah, they kind of did. If I want to. Well, okay, so how do we add fractions together? Common denominator. What's the common denominator between 1 and a? A. So if we multiply top and bottom by a, these two add together. And so basically it's 1 divided by this thing. How do you divide a fraction? Flip it and multiply, correct. So this would be like 1 times a over 3a plus 1. Just basically this. Not sure that's that much simpler than what we had to start with, but this is the version the book put. A over 3a plus 1. Alright, so what's different about number 9 than what we just did? These have no variables, so we can like solve it like the normal numbers. What's 2 to the negative 2? 1/4. What's 2 to the negative 3? 1/8. We can add those together. Yeah. All right. So we need a common denominator. So 2/8 plus 1/8 is 3/8. And all of that was to the negative 1, wasn't it? Yeah. So what's 3/8 to the negative 1? Okay. just the negative just does reciprocal. So it's just 8/3. B is kind of similar, except what did they change on B? Multiply. So this time it's 1/4 times 1/8. Multiply is actually easier with fractions, because you just do top times top, bottom times bottom. So it's 1/32, but all that's to the -1, so you flip it upside down. It's 32/1, which is just 32. Number 11. Okay, so a to the -1 is just 1/a. And b to the -1 is 1/b. We can combine those two if we do what? Have a what? Common denominator. What do a and b go into? A times b. So if this was like 1/3 minus 1/7, what do 3 and 7 go into? 21, 3 times 7. So if they don't have anything in common, you just, the common denominator is just both of them multiplied together. So this needs a b, this one needs an a. So it's b over ab minus a over ab equals b minus a. Remember the denominator just stays the same. Do these reduce right here? No. Because of order of operations, b minus a, you gotta think of it as like one thing. Subtraction and division are not opposites, so they don't cancel out. Okay, it doesn't work. B minus a, you gotta kind of think of that as one factor. I think all this was to the -1 though, wasn't it? I didn't do that part yet. So all this needs flipped. So it's AB over B minus A. Boink. This one, kind of like the last one. So it's 1/A times 1/B. What's 1/A times 1/B? Crystal, what do you think that is? This. So what's the top going to be?
1.
What's the bottom? And if this was all to the -1, what do we do with that? Flip it. So what would it be? Good job. Now look at all those A's and B's. All right. 13. Okay, now I'm going to talk a little bit more. Copy and complete the table. You don't have to do that. The cost of each item, it grows exponentially. So we need to talk about exponential growth, which I'm pretty like 98% sure we did this last year. I'm pretty sure. What letters did we use? Shoot. I think we used A, P. Does that look familiar to you guys? You think we did that last year? You guys want to guess what the P stands for? It might be a hard one. Principal. That's more of a money term. I guess we are doing money here. It's like the starting amount. It's not like Mr. Cloud principal. It's a different sounds alike, but it's not. What's R stand for? Rate. Like it could be interest rate if it was money, or it could be growth rate if it was population or something. What does T stand for? Time. Okay, so here's a really quick example. If the population of Bartlesville is 35,000 and it's growing at 1% a year. What's 1% as a decimal? Yeah, maybe the decimal twice, 0.01. So if it's growing at 1% a year, then it's basically going to be 101% of what it was. 100% of 35,000 is 35,000. That's staying the same. So if it's going up by 1%, that's why the 0.01 is right there. It's going to be 101% of what it was. And then if you do that for multiple years, like how many people are you going to have in 5 years, you need to multiply by 101% 5 times, 1.015 times. Anyway, that's how it works. And if the rate is a decrease, the R would be negative. Like if it was going down 1%, that'd be a minus 0.01. And then the population would be 99% of 35,000 after 1 year. All right. This is basically, it's kind of talking about inflation and why inflation stinks. Okay, airplane ticket now costs $300. What will it cost in 10 years? Okay, maybe I shouldn't erase that. Oh, let me write it over here, because we'll probably need it a lot. Where to put it? Thinking freshman messed up my beautiful drawings. All right, so what do I do with the 15%? Maybe I should write it. Where does the 15% go for the R? And what am I going to change it into though? 0.15. So I got like 1.15. What's the P on number 13? 300. What am I going to put in for T? 10. So it's 300 times 1.15 to the 10th power. 15% is big inflation. You guys know what the inflation in the country overall is right now? It's like 8. I think it got up to 10 at one point. So, which is bad. It's like the worst it's been in, I don't know, 40 years or something. It makes all the money that you have not worth as much, basically. So, anybody plug this in yet? 2013, 16, 17. Did it tell us where to round it? Okay, the book rounded it to the nearest dollar, so they just put 12.14. I don't think they told us, but all right. So if you have 15% inflation for 10 years, a $300 plane ticket goes up to a $1,200 plane ticket. Bad. That's in 10 years. So if we kept the 10% inflation or 8% inflation that we have now, yeah, basically we'll all have half as much money as we used to in about 10 years. Actually, let me check that. Remember how to do Actually, can somebody plug that in? That'll give us our answer. So if we kept it, so this is how long before what was $1 cost $2, basically. We did some logs last year too. We'll get to this again eventually. And she got 9, so that means if we kept an 8% inflation rate after 9 years, our money would be worth half of what it was, basically. So it's not good. All right. 15, jar mustard. So it's starting at. Oh, we didn't do 20 years. Did somebody plug in 20 already on this?
It was 4,910.
So getting out of control. You guys heard of hyperinflation? Talked about that maybe in Mr. Odell's class, maybe. Sometimes inflation gets so bad they keep making more money to try to pay for things, and there's stories of people like bringing in wheelbarrows of cash to pay for a loaf of bread. It can get crazy. Okay, so number 15, same thing. We got $1 right now, and the increase is 7%, so that's 0.07. And we need to do that for 10 years, and then we need to do that. So you don't really have to plug in the 1 on this one, right? Because 1 times whatever doesn't really do anything. So you really just need 1.07 to the 10th and 1.07 to the 20th. Excuse. All right. What's different on 17 through 20? It's a decrease. So if this is like you buy the car and then immediately the value of your car starts dropping, right? So sometimes values decrease. So their tractor costs $65,000. This would be a very old book. Maybe it's used tractor. Tractors are expensive. But it's supposed to decrease 25%. So you could put 1 minus 0.25, or, and this is like 3 years, right? What's 1 minus 0.25? 0.75. So you could just do 65,000, 75% of that for 3 years, and then do it again for 6 years. Will the value of your tractor or whatever depreciate at a constant rate? Will it be like a steady slide like that? Will it look like that or that? Okay, it's actually this one, because when you multiply by 75%, it'll go down to like 50,000, and then 75% of 50,000, it won't be as much as 75% of 65,000. So it'll, even though it's dropping by 25%, 25% of what it was is going to be smaller and smaller. So it'll drop at a slower and slower rate. And then 19 says the value of $1 now is worth $1. Very funny. And then it's supposed to drop 6% for 3 years. So 1 minus 0.06 is 0.94. So you do that for 3 years, you don't really need the 1, and then you do that for 6 years. The way they tell the value of $1 is compare it to currencies in other countries and what you can buy for them. Whether that's how they tell whether the dollar's going up or down. All right, since it's Wednesday, we only got like 6 minutes, so I'm gonna stop.